This Week in Radio Tech, episode 178, is brought to you by the Telos Zip 1 IP audio codec. Send linear or compressed audio over IP radios, private IP links, or the public internet. Great for remotes, STL, and backhaul on the web at telos-systems.com.
And now, our feature presentation.
Twert.
Would you install cutting-edge tech on a part-time radio station? Andy Linton did at Zenith Classic Rock. Why? Because he could, and it's cool.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land,
this is Kirk Harnack.
Chris Tobin joins me talking with Andy Linton from Total Broadcast Consultants in Ireland. Let's go.
You're dialed in to This Week in Radio Tech.
Hey, welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack. Glad that you're here. This is the show where we talk about radio technology, everything from the microphone to the beacon, now the new LED beacon on the top of the tower. And I've got one of our usual co-hosts joining me in studio at the GFQ network. Let's say hello to the best-dressed engineer in radio, Chris Tobin. Hey, Chris.
Hello, Kirk. How are you?
Awesome. How are you?
I'm doing well, even though it's raining here in New York and the humidity has gone up and the weather has just gone foul.
Oh,
it's annoying.
Man. Oh.
Yeah, it's summertime. It's August. I guess that's the way it goes.
Is it warm or cool this summer in New York City?
It's been a little bit of both.
Okay.
The last couple of days have been very temperate. Very nice 70 to 80 degrees Fahrenheit. It was good. But today,
I just read...
Today humidity was about 50%, very sticky, and it was around, I think, 80 degrees.
I just read last year, 2012, was like the hottest year on record. However they averaged that out, the hottest year on record for the U.S. Although globally, it was not at all. It was like the 7th or 8th or 10th hottest or 21st hottest year on record for globally. But here in Tennessee, last year, we were getting like 105, 107, 108 degree temperatures. And this year, we've been mostly under the seasonal norm. So today, high was on 86, 87 degrees. The rest of this week, it's falling. We're going to be in the 80s all week long this week. So it's really comfortable, except for all the rain. My goodness, it's been raining and raining and raining here.
We've had that here, too. There's been plenty of rain the last 2 days. And more to come tomorrow.
Let's go to Waterford, Ireland, and get the weather report from there on This Week in Weather from Andy Linton. Welcome in, Andy. How are you?
Oh, hi, guys. How are you? I'm good, thank you.
Well, you got to give us a weather report. We gave you ours.
Okay, well, up until now, we've actually had an uncommonly good summer here in Ireland. We've had some very nice sunny weather, some very hot temperatures for here. I think that the high here about 2 weeks ago was maybe 29 degrees. What's that? 29's about, is that about 85 or something like that?
About that.
Yeah, we had that, and we had a nice long stretch of it. Now, today, it got a bit cloudy, and this week's been a bit changeable. Although the weekend coming, according to my farmer, who lives over the road and is the best weather forecaster I've ever met, apart from Kirk, says it's going to be a really nice weekend.
Awesome. Well, that sounds good. All right. Well, this is a show where we talk about radio technology, and we've brought Andy Linton in. He's been on the show a couple times before, and glad he agreed to stay up late in Waterford, Ireland, to tell us a few things that are going on there. And I've got some great questions for Andy, and he's got a report for us about Zenith Classic Rock and some other projects that he's been working on. So I'm eager to hear about that. Is there any topical news that we need to cover?
I don't know if we mentioned in earlier episodes, Brian Zizik from Harris, the SBE Chapter 14 up in Hartford, Connecticut, gave him presented him with some type of an award for his outstanding dedication service beyond the call of duty to the region's broadcast stations. So I just wanted to, Brian's a good friend of mine. We've known each other for many years, and we've had some interesting times, and just caught up with a picture someone sent me recently, so from the guys I know up in Hartford. So I just thought it'd be nice to say, kudos to Brian and the work he's done, not only being a Harris rep, but doing broadcast engineering and stuff that we're all familiar with.
Cool. Hey, here's a couple topical stories that we'll open up with before we get a full report from Andy. One of them is just read in the headlines. Wheatstone is announcing compatibility with what they're calling baseband 192. The folks at Omnia, who introduced this at NAB with Nautel, call it Omnia Direct. This is the technology where you transfer the entire FM stereo baseband in a digital format using AES at 192 kilohertz sampling directly between the stereo generator of the audio processor into the digital FM exciter, and it goes with a little bit of massaging, it goes right into the numerically controlled oscillator of the FM exciter. What does all that mean? It means that there is basically no chance for junk to happen to the FM stereo baseband from the time that it was created perfectly or darn near perfectly in a digital stereo generator. This stuff's all, at least with Omni, it's all done in DSP. I'm sure it is with the other guys too. So this is pretty cool. I would expect that Orban's going to do the same thing, and it's just that Omnia did it with Nautel, showed at the NAB show. Wheatstone's been doing the same thing. What is this, Andy? You understand what this process is. What does this mean for FM broadcasters in terms of purity and cleanliness of the signal?
I see it as the last mile. Telco people refer to the last mile when they mean the last little bit. And I think it's the bit of FM transmission that hasn't been able to be digital until now. Because until now, there's had to be that analog bit of the composite signal, the composite stereo signal has had to be analog. Now it's digital all the way. I think it's a huge leap forward.
You know what's amazing though is on the composite, we as an industry, Omnia, Orban, the guys at Wheatstone, we've all done an incredibly good job of creating the stereo baseband. And this is you can do this elegantly with math and DSP, creating the stereo baseband in digital, but to send it as baseband to a stereo exciter, a digital exciter, you had to turn it back into analog baseband. Now, we were actually really good at that too, but not perfect. Anytime you convert from analog to digital, it's not exactly perfect. You always end up with a little bit of overshoot here and there, although over the years it's gotten so much better that it's darn near perfect. Many people connect to their FM exciter using stereo AES audio, just at the audio level that's been compressed and limited properly, and go into the exciter and let the exciter do the stereo generation. But in my humble opinion, I don't think that most exciter manufacturers understand quite as well as audio processor manufacturers how to do stereo generation in the very best way possible. So in my opinion, you lose a little bit doing it that way because you depend upon the exciter manufacturer to do the stereo generation and then apply that to the numerically controlled oscillator. Now, the guys that design the audio processor, what they come up with, their final recipe, their final, piece de resistance gets to go into the numerically controlled oscillator and modulate that FM signal exactly. Can people hear it on the air? I don't know, but we know that now it's by golly perfect. Yeah. Well,
but it also means, of course, that if your audio processor is not co-located with your transmitter, you might have some quite complicated and quite distant method of transmitting your audio to your transmitter site. And if it's ASEBU, that could be a long way away. And that now means that your processor can be at your studio location, but effectively it's at the transmitter side as well, because there's a transparent connection between the two, which is the best way to do it anyway. I mean, the best way has always been to have your audio processor at the transmitter site, but a lot of people can't do that. But now, effectively, because you've got an ASEBU connection between your stereo generator and the exciter, you've effectively got the audio processor at the transmitter side as well.
Yeah. And are there digital STLs yet that can carry AES at 192 kilohertz sampling? I don't know.
Well, I'm not sure about over-the-air STLs. I'm thinking of some form of microwave transmission or our national broadcaster here, for example, I'm not exactly sure what they use, but they've got ASEBU from their base in Dublin to all their transmitter sites somehow. And it doesn't really matter how it's working as long as it is. And they could then do this.
Yeah, but I guess I was referring to there are plenty of systems that'll carry AES EBU that's been sampled at 32, 44.1, 48 kilohertz, maybe even 96 kilohertz. But this has to carry AES 192, which I would imagine many systems are not designed to carry because heretofore it's not been used much.
No, that's true. That's true. But I think that's probably, I don't know. I would imagine that's, if it's not possible now, it's probably an upgrade. I wouldn't say it's a particularly difficult part of the upgrade process.
Yeah. Wow. Well, it's a good time, and I'll point out some years ago, not long after I started working with the folks at Telos and Omnia, Omnia and Nautel showed off this experimental technology that we at the time called DSET. And that was also a digital connection between the output of the processor and the modulating section of the digital STL. But that technology, it wasn't standardized. It was very customized. It worked, but it was going to be expensive to do, and it'd be proprietary. This 192 kilohertz AES is not proprietary. Anybody could whip it up and get it done. So it's been done before 10 years ago, but again, it wasn't practical to deploy on a large scale.
Yeah, it's an interesting. It's an interesting thing that's kind of just happened, and it's in a bit of an industry where sometimes we wonder to ourselves, is there anything else we can do? And it's nice when something like that comes along to kind of, if you like, complete the puzzle.
You're right, and that makes me. Is there anything else we can do? Makes me think of this notion of doing single sideband FM stereo, and folks have thought about this for a long time. I guess the Orban processors have this option now too, right? You can turn off the
latest ones do, yes.
Yeah. And we've explained the concept on the show before, but when we send the baseband, that's left plus right, 19 kilohertz pilot, and left minus right. And the way the left minus right is sent, it's a double sideband suppressed carrier AM signal centered at what's the center frequency of that? It's three times 19, right?
Yeah,
I don't know.
The 38 kilohertz you're talking about?
Yeah, that. Oh, it's 2 times 19.
38
yeah, that's
kilohertz,
right.
yeah.
The 38 kilohertz is suppressed. So you've got this, if you look at a baseband, you got this little AM signal on the baseband here. Yes, it's over an FM carrier, but this little thing is amplitude modulated. And it's double sideband. So you get the upper sideband, the lower sideband. And we found out that FM receivers, really don't need both sidebands. We had always transmitted them because it was easy to do, and actually it's kind of difficult to get rid of one of them with analog technology. But in DSP, you can very cleanly get rid of that upper sideband, which you don't need. And the higher you go in the baseband, the more that energy up in the upper frequency of the FM baseband contributes to multipath distortion. If there's multipath being received, the more energy in the upper part of the baseband contributes to more audible effects of that multipath distortion. So you get rid of that energy, and bam, your multipath goes down. And so folks have been experimenting. Have anybody doing that in Ireland, Andy?
No, I don't believe anyone's using that yet. It's something that I'd love to have a play about with, but not as yet.
I must say that here in the States, it's not a slam dunk solution. Some engineers have pointed out and even proven that in certain reception conditions, this technique does help. We had Paul Schulens on our show, a year and a half ago or so, with a video that's probably still on YouTube demonstrating driving down a very challenging reception area, a piece of road near Boston, and the audio is just terrible. And then he drove the same path with the upper sideband off, and it was a marked improvement. You almost didn't think it was the same radio station. That's the most dramatic effect I've seen. Other folks have tried it and said, nah, really can't find any places where it's different. Chris Tobin, you guys ever experiment with that in New York?
With the single sideband?
Yeah.
I did not have an opportunity. No, we didn't do it. But there was an FM station here in town that did do some testing with it. I think the folks at WBGO, they're a public radio station. They were doing some testing with it. It's interesting. I've read articles from a lot of folks who've either praised the technology and the implementation, and others that say they can't hear a difference, and then there are some that say they believe it just creates more trouble. So I don't know what to make of it. I never had a chance to really do a test. I don't know. In theory, on paper, it seems to make total sense. I know when I've worked at stations, when I used to process FM stations, and you went a little too crazy with the clipping on the composite, the demodulated signal definitely had some strange sounds in both multipath and non-multipath environments. So I could see where maybe removing one sideband could help a lot. I don't know. I think a lot of it has to do with the way people just process their audio, and by the time it gets to the composite form, what happens after that.
Gotcha. All right.
And it also is very dependent on the terrain and the topography of the area. I mean, there are some parts, some places where there won't ever be any problem with multipath. But certainly in Ireland here, Dublin, our capital city, has awful problems with multipath.
Really?
So it is some, yeah. So it is something that would be interesting to experiment with here.
Yeah,
well,
we
I
have
think you
that
could
problem
say.
here in Manhattan.
I think you could say that if some areas receive multipath interference, and the distortions and interference on a radio are caused indeed by multipath, and they're exacerbated by energy between 38 kilohertz and whatever the upper 57 kilohertz, then removing that energy would be beneficial. And so there's certainly you can imagine there are places where that would be beneficial, but not all multipath distortion is caused by energy between 38 and 57 kilohertz.
No, it could be group delay in the antenna system too.
There you go. There, it could be transmission system induced multipath.
Well,
distortion.
yeah, if you have multiple bay antenna system, you have interaction between bays and there's phasing. There's a lot of science going into that too.
Yeah. There's it almost boggles the mind when you start to consider everything that could affect it.
Oh yeah. That's why I wish I had an opportunity to work on a station with that approach, because I have a funny, sneaky feeling that a lot of people overlooking the other, as you point out, the other elements that can impact what we perceive as a multipath distortion on the receiver side.
Boy, I did some work at a station in a very mountainous eastern Kentucky area, and they had a BE transmitter. And if you ever worked with a BE tube type amplifier, they tended to use a half wave cavity, whereas most other manufacturers use a quarter wave cavity. Now, the half wave cavity has some interesting benefits, but it also has some interesting drawbacks. And it seems like one of those drawbacks, and I may be speaking out of school here, but it seems like it was very touchy on tuning, especially, I don't remember if it was the input tuning, or there was some tuning control that you could look as though the transmitter by the meters was tuned just fine, but the AM synchronous noise was terrible. And the AM synchronous noise is the variation in the output power with FM modulation. So the FM modulation would swing up and down about either side of the FM carrier, and as it did that, the power level of the output would go up and down, up and down, up and down like this. And you don't want that. You want the power level to be perfectly constant, even though the frequency is swinging up and down. So when you get this effect, it's AM synchronous noise. You can whip up a quick circuit to help you tune a transmitter for minimum AM synchronous noise. It's not always easy to do on a modulation meter. And by the way, on a mod meter, you're just measuring it at the one point you're measuring it at. But one thing you can whip up is you can make an XY oscilloscope into a poor man's tuning device. So you can set it up so that on the scope, this axis, what is that? Is that X or Y?
It's
this
X,
axis, X up and
no,
down.
that's Y, sorry.
Oh, that's why. Okay, so the up and down axis reads basically a sample of the power output of the transmitter, and the horizontal axis reads what is being fed composite into the exciter. So now you can have a pattern. If the power output is constant with modulation, then you'll see a nice, fairly flat, and usually it's just a little bit of an umbrella shape like this. So as you get excursions from the carrier frequency, you're going to be down in power just a little bit on either side. Well, a poorly tuned transmitter is just going to look like a slant line or something really awful, because the power will be varying quite a bit. So if you have a tool like that, that can really help you visualize while you crank on the controls to make it as flat as possible. If you're lucky, you can get as flat as possible to almost coincide with the most efficient operation, but not always. Most efficient isn't always the lowest AM synchronous noise. So if you make that up, and there's articles on the internet about how to make this, how to hook up an oscilloscope to do this. That's what I had to do at this radio station. I tuned that up. The owner of the station was parked in some holler, as they call it there, some valley in eastern Kentucky, and he was listening, and he was telling me how bad the station sounded, and would I adjust the processing. And so I was at the transmitter site, not even touching the processing. I had to make the transmitter right first. Got the transmitter tuned. He says, oh my gosh, it's wonderful. It's in stereo. I can hear all the highs, because his radio was blending because of just horrible AM synchronous noise, and didn't touch the processor. Fixed the transmitter. And then the next hard part was to figure out, okay, how can I write some directions for the transmitter to tune it if you don't have a scope handy? Because the next engineer wouldn't. How can I tell him to tune the transmitter that will result in this figure? And I figured out, I don't know, some peak or something in the grid what am I thinking of? Not the neutralizing, the
grid bias maybe or something with it.
Oh gosh. Chat room ought to know. One of this tube had 2 grids, right? Because it was a 4CX tube. Gosh, I'll give it a minute. Oh well. Anyway, one of the grids you had to tune a certain way. Once you had that done,
the screen grid.
Yes, the screen. There you go.
Yeah.
Had to tune the screen grid just right, and I was able to correlate that with either a peak or a dip or something, and that worked.
Grid currents usually you're dipping. You want to dip the currents.
Yeah, I dip my current often.
But who's going to do that these days? No one has tube transmitters anymore.
Well, you're right. See, he solved his problem by replacing his transmitter. Probably. Do modern solid-state transmitters have really good low AM synchronous noise?
Well, we sold one to the national broadcaster RTE here some months ago, and that was one of the specifications that they were really hot on. They wanted that to be perfect, Now, it's down to a design in the transmitter these days. You can't really tune it. It's just
right.
It's just the way it is.
So it's wide band, so it shouldn't have this kind of narrow. Yeah. I mean, AM synchronous noise is caused by narrow bandedness not coinciding with the carrier frequency.
Yeah, so I guess if they're wideband, it's going to be more immune to it, isn't it?
Yeah, it should be immune. The only way you run into a problem is if the broadband port of your transmitter is going into an antenna system that's having some issues with matching to the transmitter. That's where you'll get the nasty narrowness, if you want to call it that. Gotcha. I've only heard of it once or twice. Some people have told me. Usually, when you're on a combining system, you have combined transmitters into a single antenna system. That's where you have to be real careful.
Andy, let's talk about your project. I heard of this project, I guess, first, a couple of years ago. This, what I thought was Zenith Classic Rock. And you've told me I'm saying it wrong.
Yeah, over here we say Zenith.
That's so cool. It only has one N, Andy.
Yeah, true. And Joe, here's a funny thing. One of our guys had an idea to make some little liners using Siri. The spoken assistant on iPhone.
What did Siri say?
Well, Siri said Zenith Classic Rock, and so we said, "Oh, okay." That we were sending each other text messages with liners for the radio station.
Yeah.
And she was reading them out in the way you said, with one N, Zenith. So he said, "Okay, What are we going to do about this?" So we spelt it ZENNITH, and she quite happily said Zenith.
So you got Siri to say it the way you wanted it.
Yeah.
Oh, that's great. That's great. Does Siri say Z or Z when saying the letter?
Oh, I don't know. That'd be an interesting thing. I think she probably says Z. You see, we wanted the American voice. If you use the English voice on Siri, actually, do you know what? That's something I didn't try. Does the English or if you like the UK English voice, which is male, say Zenith or Zenith? I wonder.
I don't have an iPhone. Chris told me.
Well, because if you're talking in the States, guys, about the peak of a mountain, do you call that the zenith of the mountain?
Yes.
Yes, that's correct.
Okay. Well, that's interesting. Okay.
Yeah. So in Ireland, do you say Z or Z?
We say Z.
Yeah.
And we would say the zenith of a mountain.
Wow. I don't know. I thought we learned how to speak from you guys.
Well, yeah, but then you messed about with it.
So much for the Queen's English.
So I was reading. Here's the article, everybody. If you haven't seen it, it's in Radio World. This is the August 1st edition, and the story also occurs in their online edition too. I tweeted and put this on my Facebook as well because it's a nice little article about. Actually, it's on page 30, but there's a picture on the front in the buyer's guide looking at audio transport. Who is this fella in the picture, Andy?
That's one of the disc jockeys on Zenith, a guy called Paul Dower. He's a fun guy, and I don't know if he thought he was on the TV. No, there's no webcam, but he on St. Patrick's Day he arrived to do a show, which at the time, we'll talk about this later, was on FM. And Zenith is primarily an internet station, but it was on FM at the time. So he arrived to do his show on St. Patrick's Day dressed like that.
I love it. Well, we'll talk about the article in a moment, but first I want to ask you about this station, how it came to be. I thought it was an internet-only station, and then I came to read that you actually have some kind of a license that lets you broadcast, but not every day. What is that?
Well, Zenith is primarily an internet station. My company is a Total Broadcast Consultants. We're a broadcast consultancy and system integrator. And about 10 years ago, myself and my business partner, Andy Green, said, we'd like to hear some good music on the radio. So we got our collection of classic rock and album tracks together and started streaming on the internet. And we said we'd call it Zenith Classic Rock for no reason. We just kind of thought of it. But actually, the name Zenith was a station that Andy and I, a pirate station actually, funnily enough, that Andy and I used to be involved in the UK in the early 80s for a short period of time. So we kind of resurrected the name.
Okay.
This is about 10 years ago that we started streaming Zenith, and it kind of got a bit popular, and we did a bit more work on it, and we kind of use it as I guess you'd say a showcase for some of the things that we as a company can do in terms of the audio processing and the quality of the audio, because it's the audio processing on it is very nice, and the even the programming and the way the automation works. So we'd use it as something to mess about with, because you can't really mess about with a client's radio station because they're live on the air. So we said, we'll have our own little internet-based radio station so we can mess about with things. And it kind of escalated, and we started getting a lot of feedback for it. And then about 4 or 5 years ago, we decided to apply for what in Ireland is called a temporary broadcast license. And this is a license that exists in Ireland, where anyone, really, for any purpose, can apply for a license on FM or AM for up to 30 days a year. Now, those 30 days can be 30 days in one block, so a month, or they can be specific dates that you mention in your application. And it costs a couple of €100 for the license. There's a few other small expenses, insurance, things like that, but it's not particularly expensive to do. So you apply for this, and then they say, yep, off you go. You can have that frequency. And the funny thing about it is, unlike a lot of other countries who have temporary licenses, you can effectively here do what you want in terms of power. There's one station here a couple of years ago that decided they wanted to do a temporary license on AM with 25 kilowatts. And they were given the license. Yeah. And they were given the license to use 25 kilowatts on AM. And so here we said, okay, well, this is fun. We're going to apply for the FM. So we said, look, can we use, I think we decided on 5 kilowatts ERP. We've got an AM transmitter here, which we had sitting around for a long time, a BE AM 2.5. So we applied for that as well, which is actually out in my garage out here, because my house is, in fact, the AM site. So we applied for this about 4 years ago, and we put it on, and we decided to go from the beginning of the year. So it may not have been January the 1st, but it was whatever Saturday was the first one in the year. And we've done it every year since then. And it's kind of fun. It gives publicity to the radio station. The last couple of years, we've also had it on the DAB, the digital radio here, because my company runs a digital audio broadcasting multiplex, which is a test and development license, which is another kind of license you can get here for trying things out. So it's also been on the digital. So we do this every year, but we normally do it rather than in one 30-day block, we do it over 10 weekends or 15 weekends. So sometimes Fridays, Saturdays, Sundays. This year we did Saturdays and Sundays for 15 weeks, but live on the air with real DJs and proper programs. It's fun.
If you want to hear these proper programs, you can listen on the website is Zenith or Zenith Classic Rock.com. So one big word, zenithclassicrock.com. And I love your logo here. I just downloaded the app just now while you were chatting.
Okay, yeah, that's it.
And there it's on my iPad. I don't have an iPhone, so there it is on my iPad, and it's now playing. So you can.
They're playing Greg Lake. There's a good old song.
Yeah, that is Greg Lake. Yeah, love it. That is so cool. So how did you come about? How did you steal the Z? Is that okay?
Well, I don't think we stole it. I think it accidentally came out looking very similar to the logo of an old American television manufacturer.
And nobody said anything, so that's fine. We won't publicize.
Not yet.
I don't even know if they're still in business. Are they? Can you buy a Zenith TV? I doubt it.
I think it's one of those brands that the company doesn't exist, but some Far Eastern company owns the name.
Exactly, probably. So, how did you get the iOS app written?
Again, just there's a company that we know of here that write apps for radio stations, and we said to this guy, "Look, do you want to do one for us? We're not going to pay you." And he said, "Yeah, okay."
Okay, great. Okay, it was interesting enough. This notion of this license for your you have this license is for AM that you described, right? It's for AM?
For AM and FM.
Oh, AM and FM both.
Yeah, and we run the AM in stereo again because it's fun.
So that's interesting enough. But then you mentioned DAB. And in your part of the world, we have HD radio, which is licensed to existing broadcasters. You have DAB, which I don't know how it's divvied up, but you said you have some kind of a development authority that you can be on the air on?
Yeah, we do. Yeah. In Ireland, the only DAB or digital radio that's licensed, shall we say, as a publicly available service, is run by RTE, the national broadcaster. And they've got a multiplex on in Dublin, Cork, and Limerick, just three cities, and they've only got their own services on it. Now, some time ago, largely led by my business partner Andy Green, we decided that we should try and do something to push DAB on in this country because it was just going nowhere. RTE weren't spending any more money on it. No one knew anything about it. The Broadcasting Authority of Ireland, which is our equivalent of the FCC, were really doing nothing about it. So we said, well, there must be a way these days of doing a digital radio multiplex in software. Instead of going out and buying a hardware multiplexer, which costs a lot of money, lots and lots of money, we said, well, can we do it with software? And there's a company in Canada called CRC who've been doing some work to generate a DAB multiplex in software using a Linux-based platform. It's open source, and we spoke to them and we said, look, can we try this out? And they were delighted for us to actually try it out in an on-air environment. And there was a bit of messing about, a bit of rewriting, and we had to do all sorts of playing around with the operating system. But in the end, about 3 years ago, we got it working. So we asked our government department here who issue frequencies, can we have a license for this, please? And they said, well, there's no actual license available for DAB. However, as you're researching into it, we can give you a test and development license, which enables us to put the thing on the air for test and development purposes. And that license has been renewed every year for the last 3 years. So effectively, we've had this service on. And for people that don't know in the States, DAB, digital audio broadcasting, using the Eureka 147 system, rather than just carrying one audio channel, as iBox does, I believe, or possibly iBox possibly carries too. It carries a number, but you've got something like 2 megabytes of data which you are transmitting to the radios at the far end.
Right.
So you can divide that up.
Right.
So we've currently got 13 services on ours at varying bit rates. So we were able to mess around and change the bit rates and experiment with which ones sounded okay. And if you went down too much, down to a too small a bit rate, what happened to the audio? And we basically came to the conclusion that once the streams are above 96K, as long as the multiplex is fed with a good quality signal, that sounds pretty good on air.
Okay. Because I know that in Australia, I was just at the SMPTE conference there. They've rolled out DAB Plus in some cities, and I want to say that they're using a much lower bit rate typically. I think they're typically using 40
DAB
56.
Plus. They would, yeah. But I mean, that's DAB Plus effectively is AAC.
Oh, okay, so yours has to
whereas,
use MPEG too?
Yeah, yes, yeah. DAB,
Okay.
the standard DAB, which is effectively 20-year-old specification, is MPEG 2. Now, our multiplexer can do both at the same time. This is another thing that had never been done before, was having the same multiplexer running DAB Plus and standard DAB. And ours will run both at the same time. So we have some channels down at 48K, which sound very good because they're the DAB Plus version of AAC. And as you well know, Kirk, AAC can sound extremely good at those bit rates.
Greg Oganowski has told us so, and I believe him because we've got some stations ourselves streaming at I think 56 kilobits. Now, so I've got a couple questions about things that you've said here. And hey, Chris Tobin, feel free to jump in any time. I'm just asking questions.
I shall.
I've seen some press lately about this company called Ofcom, OFCOM, testing DAB Plus, and they seem to have a software solution. Is theirs anything like what you've used to make an ensemble or a generator or modulator?
Ofcom is the UK version of the FCC.
Oh,
and,
that's what. Okay, okay.
Yeah, that little project there wasn't. It was a funny arrangement in that there's a guy that we know very well who works for Ofcom. His name is Rashid Mustafa, very clever boy.
Yep.
And in his spare time, he decided he wanted to again play around with the same open source software multiplexer that we've been using.
Oh, okay. This makes total sense now. Okay,
it's the same one we've been using for the last 3 years. But in the UK, you see, DAB has a bit of a bad name in the UK, and one of the reasons for that is that because of the way broadcasting is done in the UK, in that generally speaking, most stations don't run their own transmission. They hand that over to a larger company. That's the tradition in the UK. Right. So with DAB, that transition, that tradition carried on. But for some reason, these transmission companies charge radio stations in the UK enormous amounts of money on an ongoing basis to transmit DAB. I know a station in Northern Ireland, for example, who are on DAB, and they have to pay £135,000 every year just to be on DAB. And that doesn't bring them in £135,000 of income.
Right.
So DAB is thought of in the UK as not being commercially successful and not being commercially viable. But the reason for that is because they've made it cost too much. So, which is one of the reasons we wanted to do this here, to show that it doesn't have to cost that much. And Rash, who works for Ofcom, decided to run his own little research project, which he did in his spare time. And again, Ofcom gave him a license to put a transmitter on for a couple of months in Brighton, in the UK.
Brighton, yeah.
And he he was talking to us about it. He got a few. He didn't bother crediting us in his article, unfortunately, but he got a few pointers from us. And he did some quite valuable research, and it kind of, and then gave it to his masters in Ofcom, and they published it, even though it wasn't an Ofcom project. But they published it, said, "Oh, thanks very much." But they pricked their ears up, which is a good thing. And I think it is going to mean that Ofcom are going to start saying, well, maybe we can start offering DAB digital radio licenses to smaller operators. Because up until now, if you're a small station covering a small town, there's no way you could afford carriage on DAB.
Right.
I was talking to a guy on the telephone yesterday who called me from somewhere, I think it was in Gloucestershire in the UK. This guy runs a small community radio station that covers a small town. And he said to me that he'd love to do this. He could get together with maybe 10 other people to get all their small radio stations on a DAB multiplex. He said to me, well, how much would it cost? I said, well, to get it on the air from scratch, from the get-go, would probably cost you about £30,000 to buy the equipment and put it on the air, and that's it, it's on. No ongoing cost apart from licensing, but no ongoing cost of paying carriage to another company. So he said, well, that's great. If I get 10 people together, that's £3,000 each. They can do that. That it becomes very doable. So I think Ofcom have pricked their ears up. They've realised that this is possible, and I think it's going to push digital radio on in the UK and probably here as well, although our regulator here are notoriously slow in doing any changes, but they're slowly coming around to it.
Well, I'm glad you mentioned... I'm sorry, go ahead. Finish.
I was going to say the strange thing here in Ireland is that we have two regulators. We have a regulator who looks after programming, called the Broadcasting Authority of Ireland, and then we have a regulator who looks after transmission, which is ComReg, which is now ComReg is a government department. They allocate the frequencies, and it appears that ComReg are very keen for digital radio to move on in Ireland. The BAI are not so keen because they're concerned about the additional competition that will provide to their existing stations, and they're a bit concerned about it affecting the income of the existing FM stations. So you've got two regulators, which are effectively government bodies. One wants to push it on, the other one doesn't, which is why ComReg have been quite happy to extend our test license for a few years. Mm-hmm. And sooner or later, the BAI are going to have to wake up and smell the roses and say, well, look, we're going to have to do this. And which we're kind of often talking to them, trying to persuade them that it doesn't necessarily mean that there's going to be huge competition to their existing stations, because it's a niche medium. A lot of people don't have the receivers yet.
Sure.
And also the stations that are going to ideally, I think, appear on digital radio are going to be niche format stations. They're going to be Zenith classic rock, or they're going to be a jazz station. So they're not going to be looking for a large chunk of the listenership.
Well, people who are looking to receive what they have found out that you're transmitting, and they know they've got to buy a receiver, which leads me to the question, in your part of the world, you've got all these DAB receivers out there, but they're not DAB+. So they won't pick up DAB+ and the codecs involved there. How do you get...
No, that's not strictly true. That's
really?
not strictly true. No, up until a short while ago, that would be true. But what has happened in recent years, in the last maybe 2 or 3 years, most receivers that have been produced in the last 2 or 3 years have been DAB+ compatible.
Okay. All right.
And what tends to happen is we have large supermarket chains here, some of whom are UK owned, and they seem to do central buying. So you walk into your one of them is Tesco's, a very large supermarket chain. You walk into Tesco's in Ireland, and there are DAB receivers there. Now, there is no commercially available DAB in most of Ireland, but the receivers sitting there on the shelf, and most of them will do DAB. Anything bought within the last, I think, 2 or 3 years will do DAB+.
Okay, so they'll do both. Well, that's good to know. That's one barrier down. Now, the next question I've got, you mentioned this open source software that you were able to put to use. Okay, you got this software. Essentially, what does the software do, and then what equipment has to surround that to get a signal up on the air?
The most complicated and difficult part of a DAB transmitter is the multiplexer. This is the piece of equipment that takes your audio from your different radio stations, however you present it to the multiplexer, and combines them into what's called an ETI stream, which is a stream of data. Combines them into that stream and puts all the correct headers and all that on them, and the program information and everything else, such that the receiver can receive them and separate them out. Because what you're doing is you're transmitting one carrier, effectively.
Yeah, okay.
And within that carrier, there is, encoded within it is a number of of radio services. So that's what the multiplexer does, and that's quite complicated. But it's not that complicated really anymore. It was complicated 20 years ago when DAB was designed, but it's not that complicated anymore. A kind of average specification computer running Linux has no problem doing that.
So this computer and let's say it's presented with audio, maybe in the AES format or whatever, but you get audio in. Is this computer doing the codec encoding and then doing the multiplexing and taking care of the headers that you mentioned? Is it doing all that?
Yeah, that's exactly what it's doing. Yeah, it's doing that. It will output. Oh, sorry. Go on. Ask me the question.
No, you were answering the question I was asking. What format comes out of the computer, and then where does it go from there?
It's called an ETI stream. I've forgotten what ETI stands for, but it's similar to a standard MPEG-2 data stream.
Okay.
With various modifications, and after that, you go to, funnily enough, a DAB transmitter, and there are a number of companies making DAB transmitters. So it goes into the DAB transmitter, which has the modulator. Now we actually have a separate modulator and transmitter for our one. And then you do need quite a clever filter afterwards. The filter's got to be very flat. It's going to be a very linear filter. So filters are quite complicated. Although as part of Rashid's experiments in the UK, he found that the filters became less complicated down at lower power levels.
Oh, okay.
Which is good, because the filters up at moderate power levels are quite expensive and difficult.
Yeah.
So you have a modulator which accepts an ETI stream, converts it into a method that the transmitter can handle, then it transmits it. As I said, one carrier. It's not one carrier. It's a number of carriers, but it's taking up a part of the frequency spectrum, and within that, there's lots of little carriers.
Yeah, I got that. Okay, so in my part of the world, the U.S., totally unfamiliar with what a DAB transmitter might look like or cost or who makes it. What are a couple typical models?
The one we have is made by Axera, which is an American company you may have heard of. There are a few European companies. I'm trying to think of one now. Can't think of one, but companies in Europe that make them, generally speaking, are not companies you'd recognize as making FM transmitters. Although Axera made one because they made a transmitter that will effectively transmit anything. And just with various software modifications, it will do DAB, and the frequencies used for DAB here are band 3 and L band. Band 3 being the one which is used the most, which is around 200 megahertz.
Okay.
And all those frequencies are allocated by the European Broadcast Union. The frequencies are waiting to be used. So that's it. So you transmit this one signal, and when you have your receiver, you do a scan of the receiver. The receiver says, "Oh, I've picked up the total multiplex," and you then have 13 radio stations, which you can just switch along with what looks like the tuning knob. But of course, it's not doing any tuning. It's selecting different streams from within that data stream that the radio is receiving.
When I was in Australia a couple of weeks ago, I actually produced a little video, but I didn't get a chance to show it because it didn't come out that well. But a friend of mine, actually the guy who's the director of engineering for Southern Cross Austereo, the biggest commercial broadcaster in Australia, he loaned to me for one day a little DAB Plus receiver, and it was a little smaller than, say, this cell phone, but about the same. It was about the size of an iPod. Right? And it had a little antenna that came out of it like this, and a beautiful screen. Now, it wasn't quite as slick as an iPod in terms of its operation, but it was mostly touchscreen, and you got not video, but you got still pictures of each station, and it would scan. And right there in Sydney, Australia, I think it picked up 60-something stations altogether off of 3 different ensembles.
Yeah. And to the listener, there is no difference between those ensembles. They just get a list of stations that their radio can hear. They don't know what ensemble it's on. I mean, you can scroll around the display and find the name of the ensemble and the frequency it's on if you want. But to the listener, there's no indication. It's just, here's a list of stations, often in alphabetical order, which they can listen to. it's very user friendly to non-technical people. It's a good medium. And one interesting thing that we've experimented with here is single frequency networks. We actually have 3 transmitters on air here. One from a high site using 100 watts ERP, and 2 using much lower power, about 1 watt, from in Waterford City, which is about 5 or 6 miles from me here, and another one a short distance away. But they're all on the same frequency. And the way it works, don't ask me how this does work, but the way it does work is that where they overlap, they actually add to each other. So you don't get any problems where, as you would on FM, where if you have 2 transmitters on the same frequency, unless they're synchronized, you get a hash in the middle. Even if they are synchronized, you're still going to get a certain kind of hash area.
Isn't this the benefit of COFDM, this type of modulation? The competing signals, as long as they're the same, actually add together or can be added by the receiver.
That's right, and it works extremely well. I mean, I can drive from my house here, which is actually, I have to say, in County Kilkenny, not in County Waterford. Waterford's 100 yards over there, but I'm in Kilkenny. But I can drive from here towards our main transmitter site, and I can look at the signal strength on my DAB radio in the car, and as it moves away from the Waterford transmitter, the signal strength goes down, and then it comes up again as I get to a place where I can receive both. Then it drops off again. Then it comes back up again as I approach the other transmitter. It's kind of strange. And there is no audible indication that anything's going on.
Similar to a cell phone or mobile phones.
It's yes and no. It's not handing over from one transmitter to the other. It's picking up both signals at the same time.
True. Yep. Okay, yeah. But in order for the mobile phones to operate, they do have to have the same signals. They overlap, and then they hand off, right? Okay, yeah, you're right. Well, that'd be an interesting, an interesting approach here in the States to try and accomplish. Oh, no, that's right, it wouldn't work.
And an interesting thing that experiments have shown is that in terms of radiated power levels, if you have, how should I put this? If you have an FM transmitter radiating 1,000 watts ERP, in order to get the same useful coverage with DAB, you would be 10 dB down. So 100 watts ERP would give you the same coverage as a kilowatt ERP on FM.
Yeah. That's not unlike HD radio here, where they've recently raised the power levels, but they used to figure 20 dB down would give the same coverage. Didn't quite. 10 to 14 dB down gives similar coverage with HD. But the principles all apply there. Digital's digital.
So, Andy, this is Chris. With the DAB receivers, I know I've looked at a couple of websites and they have battery-operated ones or portables. Would you say the experience, the reception, is equivalent to or very close to what you currently have with FM? I'll call it traditional analog. As far as reception, walking around.
Yeah, well, if the received signal's good, then there's no difference as the signal goes up and down. It's digital, so the audio is there and it's as good as it can be. However, there are certain things that happen as the signal gets weak. Unfortunately, there's with standard DAB, it starts squeaking and popping and banging when it drops out, which is a bit objectionable, I have to say. Now, a lot of receivers have muting, in that rather than squeaking and I mean literally squeaking and shrieking, they'll mute. And if you're using DAB Plus, you tend to get a kind of a stutter effect as it repeats the last little bit of data that it got if the signal drops out. But I don't know. If you're going to get a good reception in the same geographical area than you would get with FM, then you're going to get perfectly good reception and perfectly good audio quality throughout that area. It's only when it gets weak is that funny things happen.
Right, I understand. I've spent 10 years plus doing HD radio installs and development work, and I've still have had difficulty experiencing the same quality FM in the mobile environment as I with the HD radio as I have with the analog FM. And I recently had some friends tell me they've purchased some new cars and driving around and said they have this thing called HD radio, but it's constantly cutting out or it changes audio. I don't know what the deal is, and they stop listening to it. So I'm still fascinated by the mobile bit error rate ratios that people claim are good or bad or acceptable. That's why I was just curious what your experience was, because I would think if you had a single point of source of transmission, you could probably better control what the expectation should be for the mobile environment, signal quality, error correction, a whole bit. Whereas here in the States, HD radio is literally individual sticks. Everybody just transmitting all over the place. But your description, multiple carriers on a single receiver being received, and you just, pick out the slices you want to listen to. I would think in some, on a theoretical level, you could actually have more robust control. You
can, and of course, yeah. If you're in a built-up environment, if you're in a city where you are going to get signal dropouts, then it's very easy to put a little fill-in transmitter. It might only be 100 milliwatts to cover particular parts of that area that are experiencing bad reception from the main transmitter. Very easy to put that in, both technically and license-wise. The FCC or the Ofcom or Comreg here are not going to mind you putting on a 100 milliwatt transmitter to cover a small part of a city. Once you've done that and you've cleaned up all your poor reception areas within your coverage area, then you are going to get very good contiguous reception throughout that area.
Okay, so you use filled transmitters to fill in the gaps, and with the technology and the capability of having the single frequency networking technology, I'll call it. Yes, you could build. Okay, I see. All right, that makes sense. That makes total sense. Do you see that approach taking place in your part of the world? In Ireland, do you see broadcasters considering that model from a business standpoint? If I'm a legacy broadcaster, or maybe it's RTE or somebody, and I've been doing X number of pounds a year, and everything has been great. Now I have to spend a couple extra dollars or pounds to fill in. The business mindset, do you think broadcasters would even consider that or look to that solution?
I don't think so. And the reason I say that is that DAB has, certainly in the UK and here, been regarded as, or it was, I think, erroneously marketed as a future replacement for FM.
Yes.
And I don't think it's a replacement for FM. 20 years ago when they introduced DAB in the UK, there was all sorts of advertising that said, this is better quality than FM. Now, it has the capability of being better quality than FM, but of course what happens then is the accountants come along and say, we can squeeze some more stations in this, let's cut the bit rates down, and then of course it's not as good quality as FM. That's the mistake they made in the UK. So I don't think it should be considered as a replacement for FM, and I don't see existing broadcasters seeing the advantage of moving to DAB or even simulcasting on DAB. But what I do see is that DAB should be a medium for alternative broadcasters, smaller scale broadcasters. I mean, I can't remember how many it is, but it's not many FM channels available in any one area. It's not that many, is there? But if you have 2 or 3 DAB multiplexes, you can quite happily, as Kirk said, get 60 stations on. And if costs are kept sensible, it can be financially viable for those small broadcasters to spend, $2,000 a year on transmission. If you spend $2,000 a year on transmission, you're doing very well. You couldn't do that with FM.
No, you're absolutely right. No, I agree. Okay. That makes total sense.
So I see it as an incremental medium to FM, not a replacement. Now, that's sometimes a controversial view and not one that everyone here shares, but I think that's the way forward with digital radio here, is that it's a medium that should be designed for smaller, niche format radio rather than just a replacement for FM.
I agree. Okay, I agree.
It's an interesting outlook. I might argue or point out that though, if it's just a bunch of niche listeners, how are you going to get the big momentum of the larger populace buying DAB radios and being able to tune that in? It seems to me that the big broadcasters would help bring that along. In fact, in Sydney, for example, I noticed that the big broadcasters now had no power advantage and no dial position advantage over the niche broadcasters. They were all listed either in alphabetical order or by ensemble or by group of stations in your radio. So everybody became on an equal footing, which of course wouldn't make the big broadcasters all that happy, but it sure made the little broadcasters happy. Equal footing for everybody.
Yeah, and there's nothing wrong with equal footing, though. I mean, now that means you just have to take a different approach on how you brand your product and how to reach your audience. And if you really have a product that people want, it doesn't matter if it's alphabetized or if it's random or if it's louder on the dial or a bigger button. I mean, they'll find you, and that's the part that I think the bigger broadcasters keep missing out on. They're stuck in the days of push-button radios in the car and the little clip-on button that remind people which radio station you should be pressing for that button. And that's
content. Let's face it. What are listeners interested in? They're interested in content. They don't particularly care whether it's on FM or DAB. If that person wants to hear nose flute music and there's a station doing it, then they'll find it and they'll listen to it.
Yeah.
And I think what does tend to happen, certainly here, we found is that if someone decides they want to buy themselves a new portable radio or kitchen radio or something, they'll go into the supermarket, they'll buy a radio. They don't know what this radio, it's a radio. And they come home, they plug it in and they switch it on and the radio says scanning, right? And it finds a load of radio stations that they've never heard of before, and these people are delighted with that. They don't know they don't know how they're getting there, and I think that's the point. Is that I think the point is that the vehicle that brings that audio to those people's ears is irrelevant. It's what's in the back of that truck, not the truck itself.
Absolutely,
that's a good point.
Absolutely.
A good point. Hey, I want to remind everybody you're listening to and watching to This Week in Radio Tech. It's our 178th episode. Welcome in. Glad you're watching or listening. We've gone through almost a whole hour here, and I haven't broken in to tell you or remind you. Our guest this episode is Andy Linton. He is an engineer from Ireland, and he and his partner, Andy Green, run a company called Total Broadcast Consultants. And they build radio stations. They fix broken ones, and they used to run pirate stations. They don't anymore. Now they run fully licensed radio stations, and one of them is this awesome station called Zenith Classic Rock. And we'll finish up in a few minutes talking about that. Right now, I want to remind you who makes it possible to bring you this program. It happens to be my employer, and I thank them very much for sponsoring the show, the Telos Alliance. And this episode is brought to you by the Telos Zip 1. There's the web page for the Zip 1. The Zip 1 is an IP audio codec. So it takes audio in, turns it into IP streams, and sends it in a very intelligent way to another Zip 1, which decodes it and gives you audio back. You can do this over the public internet. And that's not altogether magical, the public internet, but what is cool about the Zip 1 is it gives you the most use of your public internet connection that you have. In other words, it always gives you the maximum bandwidth available at the lowest possible latency from one end to the other. We've designed that in with agile connection technology. By the way, if you don't need that agile connection technology, you can turn it off. You don't have to use it. But if you're using a shared connection, you probably do want to use that. Hey, if you'll switch the camera back to me, I've got a Zip 1 right here behind me, and I'll tell you what, just a moment ago, I dialed up another Zip 1 that happens to be in Sydney, Australia. I'm in Nashville, Tennessee, and
3 words: self-interest rules.
There you go.
I mean, that's just what it's about. Remember also,
that's a radio station in Sydney, Australia called Hope 103.2. And you can dial up lots of stations, although that's not the goal here to dial up radio stations. The goal is to get your audio from one place to another, whether it's a broadcast remote at the car dealer or the county fair, back to the radio station or the rock concert, or getting your audio from the studio to the transmitter site. Now, Andy Linton, our guest, has an interesting application for a Zip 1. There's a picture of it right here in this article. I mean, there we go. You can see it there in the top of the screen, the Zip 1 in the rack. Andy, what are you doing with the Zip 1 there at Zenith Classic Rock?
We spoke earlier how at Zenith we were able to get a license to broadcast over the air once a year for 30 days.
Yeah.
So this year when we did this, which I think started on January the 5th, I think it was, in previous years we've used a composite link at something like I think 1.4 gigahertz to get to the transmitter site, which is about 35 miles away.
Wow.
But in the interim, we'd moved where the studio was to a different location, and there was no line of sight shot. So our building where the Zenith studio is, or the studio which we as Total Broadcast rented to Zenith, even though we run both things, they're separate organizations, is at our office, and we have a very good cable internet connection there. And at the transmitter site, we were able to put in a fixed wireless internet connection at the transmitter site, which is, I think, as I say, about 30 miles away. So, we thought, let's get hold of a pair of Zip ones and try them out. We literally came along, plugged one into the studio. The studio is an Axia studio, so the live wire connection between the studio mixing desk and the Zip one worked perfectly, of course, straight away. We did that up to the transmitter site and plugged that in. The two Zip ones get their IP number from the DHCP server, and we just went. It was the first time I'd played with a Zip one. I'd heard Kirk and people talking about how clever this was. The first time I'd play with it, go into the directory, click, click, click. There it is, Zenith Studio, connect, and it just goes blip, and it's connected. And I think we had audio 5 seconds later. Perfect audio, and we were sitting there looking at the logs and looking at what was happening to the internet connection at both ends. And there were occasions where that internet connection would drop down quite badly. I mean, the fixed wireless internet connection at the transmitter site is on the back of, I believe, 4 or 5 microwave links. So all sorts of bad things can happen. While I have to say that the audio did drop out maybe 3 or 4 times over the space of 15 weeks, that was because the internet connection literally dropped out completely. There was no upload capacity at all at the studio end for whatever reason. But having said that, there were other occasions where the upload and the download, or one or either of the two of them at either of the two locations, dropped down quite badly. But the codecs hung on and gave us very good audio. We were using 192K AAC.
Yeah.
And sounded perfect. Sounded very, very good.
You bring up an interesting point. The Zip One actually is capable of scaling from 320 kilobits AAC, and it will automatically, if it has to, if you run out of bandwidth, it'll downshift to high efficiency AAC. It'll change codecs altogether and give you down even to as low as 24 kilobits per second. It has this range of speeds all automatically if you want to give it that range of speeds. I got another thing to announce here is that the Zip One now optionally has aptX encoding. This is really popular, especially in Europe, but a lot of broadcasters like aptX for its very low latency. And so this particular Zip One has aptX. I'll click connected, and I'm getting connected to another Zip that also has aptX. And so you've got only about 3 or 4 milliseconds of coding delay with aptX. So if you're interested in aptX, it's an option that's now available in the Zip One. We spent enough time on it. If you're interested in the Zip One, the IP audio codec, lots of folks are using it for STLs, for remotes. As Andy said, you're sending this out to your DAB site, right? Your DAB transmitter site?
Yeah, that's correct. Yeah.
And check it out on the web at telos-systems.com, and then click on the Zip One link and read about it for yourself. All right. Thanks to Telos for sponsoring us, and for the Zip One for being such a cool product to make it worthwhile for broadcasters to get audio from here to there. Andy, we want to wrap this up pretty quick. Why don't you tell us, what haven't we covered that you wanted to cover on the show here? Anything? Well,
just in a slight addendum to what you just said about the Zip One, about our experiences with it. I know we've moved away from the sponsorship, but it's interesting to let you know that one of our clients is a radio station here in County Wexford, and they were doing a broadcast for a full week from the National Ploughing Championships. Imagine.
Okay.
Yeah. Now, that of necessity was from a field. And they were provided with, again, fixed wireless internet. They did 8 hours of programming every day for 5 days, and that codec didn't let go once.
Oh, my goodness. What a great story. That is amazing. If the bandwidth is there, the Zip One will get through. And that's the whole idea behind it. Most other codecs it's not that they're stupid. It's just that they don't automatically shift gears and change. You have to set the bit rate for the lowest common denominator. You have to set it for the worst case situation if you want to stay on the air. And the Zip One will automatically shift gears and adjust to the available bit rate within the parameters that you set. So there you go. If folks want to know about Total Broadcast Consultants, I guess for the right price, you'd travel outside the country to do some work. Where can they visit?
Absolutely.
Visit your site?
Yeah. We have done. We've traveled all over Europe to do a bit of work for various people. The website is totalbroadcast.net.
Totalbroadcast.net. And Zenith Classic Rock is at
zenithclassicrock.com.
Cool. All right. Yeah, if you're a rock fan like I am, and like so many people are, you're going to enjoy the programming there. Give it a try and download their app for iOS devices. It's free, and you'll get.
And I've got to tell you guys, it's not your standard classic rock station. This does not just play More Than a Feeling all week and all day. There's some good deep album cuts you'll hear on that you won't hear.
Oh my goodness, he said album cuts. Excellent.
Yeah. The way rock stations used to be.
Yes.
I remember them. Yeah. All right, Andy, it's been lovely having you on. I know it's 2:30 in the morning there. Oh, there goes my webcam again. It's 2:30 in the morning there, so thanks for staying up for us.
Yes, thank you very much.
It's a pleasure talking to both of you there.
All right. Chris Tobin, thanks for being with us in studio there at the GFQ Network.
Oh, you're welcome. I just got to make sure that somebody's here in case that bandwidth gets choked.
Well, my bandwidth gets fine, but I'm about to throw my Logitech camera out the window. Oh, wait a minute. No, Andrew gave it to me. I can't throw it out the window. Maybe I should just update the drivers.
No, just put it in a little bag, put it in the post, ground service. It'll get here in some form or shape, equivalent to tossing it out the window.
All right. Hey, my video is so bad. Chris Tobin, thank you, Andy Linton, for being with us. Chris Tobin, why don't you walk us out of the show?
Very good.
Next week.
All right, well, this week in Radio Tech concludes with Andy Linton from Ireland, 2:30 in the morning, and we appreciate him being a trooper and staying up late and talking with us and going crazy as we all do here. And Kirk Harnack, who's back at the home headquarters of Harnack Mansion, is experiencing some extremely blooming video, lots of light going on. He's been drinking something that was an amber-colored drink that had some ice cubes in it, I think. I'm not sure. It's obvious the video is just going.
It's a Tennessee thing.
It's a Tennessee thing, exactly. He's having great weather and everything else. And I'm here at GFQ Studios, out at the home base, basically our network operations center, if you want to call it that. And I'm with the folks we do Musicam codecs, we do video, we do audio over IP, video over IP, and many other things coming this fall. So, anybody looking to find me, as you've always done in the past, just C. Tobin at musicamusa.com. I'd be more than happy to talk. And actually, this week we had some folks emailing. Somebody emailed me about soundproofing their studio, their home studio. Remember, soundproofing, sound transmission, two different things. You want to soundproof the room, you got to build the walls so they really don't allow transmission through. If you want to just acoustically deaden the room, then that's just a surface treatment. Those are the two different things. That was the email I got. I just want to. Yeah, somebody said I got this material I put on the walls and I can still hear my kids on the other side. I'm like, yes, you probably can, because I bet those walls are standard sheetrock, studded, So those are the two things to remember. So the internal, sound reflections in the room can be controlled with surface treatment. Sound transmission from point A to point B through the walls, that's construction. That's a whole different approach.
You could almost treat a room such that you couldn't hear yourself that well, but you could hear the guy in the next room fine.
Absolutely. So that concludes our netcast of This Week in Radio Tech. And which I didn't even look to see which episode we're doing here. This is not good.
It's 178. I don't know who the guest is next
178. It's 178, episode 178. As always, it's available on demand. It'll be ready in a short 24 hours from now. And then there'll be show notes and everything else, so you can links to click on and a lot of great stuff. And again, thanks to our sponsor for being such a great group of people, the folks at Axia. And that's about it. So I guess that's where I just back away and say ta-ta for now. And again, Andy, thank you very much for being a trooper and staying up late.
You're welcome.
Kirk, be well, and stay away from that stuff because it's affecting your video.
Apparently so. Good night, everybody. We'll see you next week on This Week in Radio Tech.
That's all the bandwidth we can pilfer this week. Another twit has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech.
Subscribe to iTunes and you'll never miss a show.
Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you liked today's show, tell a friend. If you didn't like it, we were never here.
Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission.
Tango, Whiskey, India, Romeo, Tango.
Signing off. Okay.